Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on the force exerted by the jet on the inclined plate moving in the direction of jet. Actually, this topic belongs to impact of jets, where we have discussed many conditions related to the impact of jets with the plate is in inclined condition, the plate is in vertical condition, the plate is in a curved condition. These are the conditions of the plates or types of plates also you can say, and whether the plate is in moving or stationary condition, that also we have discussed for stationary. Now we are discussing about the moving plate. Okay, so this topic is actually belongs to, as I told you, this is impact of jets, and here we need to find out the force exerted by the jet on the inclined plate which is in moving condition in the direction of jet. Okay, let's see the problem here. So problem, I have taken a 7.5 centimeter diameter of jet having a velocity of 30 meter per second strikes a flat plate. So how to identify this problem belongs to what category and what kind of problem formula will be used for the particular problem. So in the question itself we can identify. Now see, this is the jet diameter given having a velocity. The jet diameter is moving with a velocity of 30 meter per second and that strikes a flat plate, the normal of which is inclined at 45 degree to the axis of the jet. Find the normal pressure on the plate. Find the normal pressure on the plate when the plate is in stationary condition. Two types are given when the plate is in stationary. Another one when the plate is moving with a velocity of 15 meter per second and away from the jet. Also determine the power and efficiency of the jet when it is in moving condition. Obviously, the power and efficiency will be calculated when the plate is in moving condition, because to calculate the power we need to calculate the work done. So work done when it is possible when the plate is in moving condition. Anyway, so this is the question given. Based on this category of problem, we have already discussed the derivations in our last lecture. So there we have identified the force exerted by the jet of water on the inclined plate when the plate is in moving conditions. Okay, so just will solve this problem by using the formula here. So let me write down what are the data given here. So this is the solution, let's mention it, and here I'll write one by one. First line itself we can see the diameter of the jet is given. So diameter of the jet is nothing but this is the jet. Okay, this one actually pipe through which the water is coming, and this is the nozzle of the fluid flow through which the fluid is coming out and which is connected to this pipe, and this is actually the jet. So the jet is moving with circularly, so the diameter of this pipe is given. So the diameter of the jet is given. So this is the diameter of jet. So this diameter of the jet is given 7 point. This is diameter of the jet. This one we can write D, and this one 7.5 centimeter, and this one we can convert into meter. So this is nothing but 0.075 meter. So from here we can also able to calculate the value of area, the cross-sectional area of the jet. So diameter given, so we can calculate the area of this. So that is formula is pi by 4 d square. We can calculate this. Now the next one is the velocity. The jet velocity strikes the flat plate. So the jet velocity, we can write this is velocity of jet. This one we can mark it V of 30 meter per second. Okay, and strikes a flat plate. So strikes a flat plate. This is the plate. Okay, actually this is the plate, inclined plate, not flat. Okay, so now we can take the condition of flat plate. Suppose so this is the flat plate is there. Okay, and vertical condition. The plate may be inclined or may be vertical. So that based on the angle actually. Okay, so this is vertical. Now here I have taken inclined condition. The normal of which is inclined. Now see, this is the inclined point given. That's why I have taken this inclined plate with an angle to the axis. So the angle to the axis is given 45 degree. So that is, if you see the normal force which is acting here, or we can say the normal force which is acting to the plate, this one. So this is the plate is there, and this is the normal force. This is perpendicular. Okay, this is perpendicular. If you see the angle between this jet and the plate is theta, already given here. You can see this is theta, and if this is 90 degree, then what about this angle? Obviously this will be 90 minus theta. So here what is given? The velocity of the jet is given 30 meter per second if it strikes the plate. So velocity, this one, this velocity given 30 meter per second, strike the flat plate. The normal of which is inclined, see the normal of which is inclined at 45 degree angle to the axis of the jet. Axis of the jet is this one. Axis of the jet is this one. So this is given 90 minus 45. This 90 minus theta is nothing but 90 minus 45. So this angle is 45. That means the theta angle also you can identify here. So the angle between the jet and plate is nothing but theta, as I told you. So we can calculate angle between plate and jet. Plate and the jet, that is nothing but theta. So how we can calculate? This is 90 minus this one. You can see this theta actually how you will get it. Simple. The 45 degree angle given this one. So here what we will do? This is 90 minus 45, will get 45 degree angle of theta. So now we need to find the normal pressure on the plate. That means what is the impact of force on this, or what is the force of normal force on, which is acting on this plate. And when you need to calculate, when the plate is stationary condition. One is when the plate is stationary condition, another one is when the plate is moving with a velocity of 15 meter per second. Now see, after giving impact, the plate started moving, this u, small u. So again we can write, this is velocity of plate. One more data, this one we can write, this is small u, and small u is given, this is 15 meter per second. So these are the data are given for our problem. So first of all, we need to find out the point A or point I. If you see, when the plate is stationary condition. So when the plate is stationary condition, we know that the normal force which is acting on that, that is Fn. That is Fn equal to, the formula is rho Av square. This is sine theta, because here actually the plate is inclined. That's why the normal force for particular this, when the plate is stationary, not in moving condition. Okay, we got this formula, that is rho Av square sine theta. This formula we got, we already derived in our previous video lecture. So there you can identify this, and this one we just put the value of, see here rho equal to, that is density. So density of what? Density of the liquid. So the liquid is here actually, that is you can see diameter of the velocity. Yeah, here density actually, here we can consider this is water as the fluid which is flowing, and the density of the water is nothing but 1000. So here I can write density equal to 1000 kg per meter cube. So I'll write here, this is 1000, and area equal to, here we need to find out area actually. So let's find out the area. Pi by 4 d square. So pi into d square. This is 0.075 square and divided by 4. 0.0017. So we got the value of area equal to 0.004417 meter square. I hope the same value we got, 0.004417. Okay, so this is the area. Now what I'll do, I'll just multiply this one, multiply 1000, then v square equal to how much? 30 square, that means 900. We got this value into, okay, into what I'll do, into this value I can write here, then otherwise it will be gone. So let me write here first. This is area equal to, this is 0.004417 into This is 30 square into sine 45 degree. So we got a value of multiplication. We got this value 3939. This is 76.3976.08 something we got into sine 45. So this one multiply. I'll do bracket start, and this is 45. So sine 45 bracket close equal to 2811. So this is sine 45 and 45. This is 1 by root 2 actually. We get the value. Anyway, we got this value here 2811 point some 1 or 2 something we got 51. This is this much Newton. This is one answer. Okay, this is one answer of first question. Now the second question we'll see. The second question is when the plate is moving with a velocity. Plate is moving condition. Plate is in moving. Okay, for that what is the formula? And here the after moving the plate moved away from the position, and it is away from the, you can see away from the jet. Okay, that's why the plate moved here with a velocity of 15 meter per second. Now for this actually another formula is there. So here we know that we need to calculate the Fn value, the normal force, okay, to this one. So this value is actually we need to consider rho A. Same thing will be there, only one extra velocity will be subtracted here because that is relative velocity we should consider there, and with multiplication of sine theta. So this is the formula here, and all the values we know here, so just put the value. So let me write here, this is the value. Yeah. So v minus u square, that means 30 minus 15, so 15 square. So this is again 1000 into 0.004417 multiply. This is 15 square, that is 225 into again bracket start 60. This is sine of 860. We got the value here, it is 860. So let's check it again. So here also let me check it. 15 into 15, 225, correct. And this is, let multiply 1000 and multiply this area equal to how much? This is 0.004417. So we got 993. This one we got 993.825 into sine 45 into bracket start 45 trigonometry sine value equal to this. So 702. Okay, previously I have entered I think 60. That's why it came wrong answer, because that is not related to this same value. So this is sine 45 equal to, we got 702.5 something we got. Yeah, 74. This is 74 Newton when the plate is in moving condition. Okay, so these are the two answers for the first two points. Now the third point is given, also determine this one, power and efficiency. So to calculate the power, first of all we need to identify the value of work done. Okay, the value of work done per second by the jet. So what I'll write, the work done by the jet, or work done per second by the jet. Work done per second by the jet. You can write this. The formula is nothing but is equal to the force. Okay, the force in the direction of jet. The force in the direction of jet. The force in the direction of jet into the distance traveled, into the distance traveled by the plate, the distance traveled by the plate in the direction of z. So the distance traveled by the plate in the direction of z. Okay, so in this direction of z. So here the force in the direction of z is nothing but this one. This is Fx, and here normal force we have calculated, correct? This is normal force we have calculated. This is Fn. So here angle is there 90 minus theta, and we need to find out the Fx value. So here actually, to calculate the work done, we require this is equal to Fx into distance traveled by the jet per second. One more thing, by the jet per second we need to consider, so that we'll see distance by time. Distance by time is nothing but velocity of the plate. So we can write Fx into u. So what about the Fx value? Fx equal to, we'll get here Fn sine theta. Fn sine theta, that will get from here. This is 90 minus theta will get, because here 90 minus theta, this one also 90 minus theta. So if I resolve the Fn in this Fx direction, so that is Fn cos 90 minus theta, that is Fn sine theta will got. Anyway, so Fn already got the value. How much is this? Is 702.74 into this is sine 45 degree. Okay, so let me calculate this. 702 already there, multiply bracket start 45, again 300 value sine, this is 496. So here I got the value of Fx equal to 496, this much. Now again this will need to multiply with respect to 15. So this is 7453. Okay, so this is, let me write 496.91, 496.91, this much Newton, and work done equal to this is nothing but 496.91 into u. U is velocity of the plate, this is 15. So finally what I got, 7453. 7453.69 something is there. So this much work done I got here. This is Newton meter per second, I can write Newton meter per second. So what about the power? Actually I need to find out the power value here. So what about the power here? I can write this is power equal to power in kilowatt. Power in kilowatt. So just you divide 1000 on this. So we'll get, this is nothing but 7453 point how much we got, 69 divided by 1000. So equal to, we'll get, this is 7.45 kilowatt, this much power. Okay, and finally the last one is nothing but efficiency. So efficiency, we know the formula, this is output by input. Efficiency formula is output by input. Output is nothing but the work done per second. Output is nothing but the work done per second by the jet. So that is our output. So output, we got the value, how much work done by the jet is nothing but, we got finally, this is 7400 something we got here. Yeah, this one. See, this is the value of output. So write down the value of output, 7453.69. What about the input? So input is nothing but, that is kinetic energy of the jet initial. At the inlet condition, what is the initial condition? What is the input? So that is nothing but kinetic energy of the jet. So this one again we can write half mv square. Half mv square. So half mv square again we can write what is the value? M equal to, I can write rho AV. Rho AV. So rho AV into v square. So we can write this is 7453.69 divided by half into rho. Rho is nothing but 1000 into area. Area already there. This is 0.004417 into VQ. V, this VQ. V square V. So that is nothing but 30 Q. So finally we can find out the efficiency. So let's calculate this. First I'll calculate the denominator part, then we'll go for the numerator part. So this, otherwise we can do, let's try it, divided by, so this is 0.5 multiply 1000 into 0.0044 this is 17 into this is 30 30 30 bracket close. Yes, it came the value. So 0.125. So this is 0.125. So finally you can write the efficiency of this moving jet or moving plate is nothing but 12.5%. 12.5%. So this is our final answer. So I hope you understand how to solve it. This is the power, this is the efficiency, and this is the force when the plate is in moving condition, and this is the force when the plate is in stationary condition. So I hope you understand this problem. Still, if you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you.